Hey all, this is the first in a series of videos for our asynchronous class. I've got my M8 in-class submission opened up. Just gonna work through some of the pieces here. You can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 sheets. So fairly significant assignment. Break it up over multiple days. Give yourself time. The first two sheets are really revisiting things that we've already done. So create a histogram, find the mean and median, explain whether the distribution is normal or not with evidence. Let's just pull up the instructions so we can be clear about what the histogram expectations are. Okay, glad I checked because it says use either Excel's histogram tool or you can make a pivot table. Really, this or statement should be any kind of process that you want to go through where you're creating a frequency table to create the histogram. I don't care in this step one. That's the point of saying you can use Excels to do it. And given how extensive this data set is, let's just do a control shift down check here. This is 20,000 data points because there's a lot of artists out there. I might consider just using Excel's tool. So remember to do that, you highlight that column. You may actually, this text might get in the way, so I'll do the control shift down thing and then do insert and then the histogram here. Boom. And it produces a histogram for me. Give yourself more space so you can actually see what's happening here. This is a little hard to read. And then, of course, you're going to put your title and your labels on all of that. Scroll back up to the top. And then find the mean and the median and explain whether the distribution is normal or not with evidence. So all of that we've practiced doing before. I think that's all pretty self-explanatory. Let me go back to here. Mean and median, distribution is normal, good. All right, and then step 2, we're going to do it very similarly, but we have a shorter data set. Let's do control shift down and see what we're talking about. 5,000 points here. All right, so that's a smaller data set. And then find the mean and the median, explain whether the distribution is normal or not with evidence. So those, you're repeating yourself twice, practice. Right? We've done so much practice with normal or not, making histograms, talking mean and median, looking at skew. That's really important. I want you to feel confident about that. All right, but let's talk about this second part of this here with the Z-score question. So we want to find the Z-score for a person that's 132 pounds. We want to interpret the Z-score in 2 ways. So in order to not do the question for you, let me show you how I would do the question. Let's say that I have some data. Let me just grab a little bit of data here. Okay, so I've got some height data. Really, to apply the Z-score in a meaningful way, we need the data to be normal. So I'm skipping over that step here. I have looked at it. It is normal-ish. But that is part of what makes this work. It should be normal. Just giving you kind of a clue there. Okay, so find the Z-score. And I'm going to do a sort of a parallel problem using the height. So let's say a woman has a height of 6 feet tall. And I want to find the Z-score. I want to interpret the Z-score. And so finding the Z-score, what other measures do we need to finish this problem? This is checking in on your understanding of it. I would pause and see if you can remember what that is, but I'm going to go ahead and do the things that I need. I'm going to do the average, which is the mean, because I need the mean for the Z-score. And then I need the standard deviation. I'm going to go ahead and label this. And when I do the standard deviation, I need to know whether I'm doing the sample of the population. What's important here is, do I have everybody in the universe that would be in the population? And if the answer is no, I'm going to use the sample, not the population. So look at your question and see, for these 5,000 people that we're talking about, is that everybody that there is, or are there other people out there and the 5,000 is just a sample? So I've got my numbers here. And we're going to go ahead and find the Z-score. So 6 feet tall is 72 inches. That's just 6 times 12. And so now I'm ready to do my z-score calculation. So equals 72 minus the mean divided by the standard deviation. Got that parenthesis backwards. I'm using cell references because I don't need to type this in. And even if I had kind of rounded these values, I would like to do it as exactly as possible when I calculate. And that's, again, a strength of Excel to just reference, brings the whole number over. We've got a z-score. And so now I'm going to interpret this in two ways. So this woman is more than 3 standard deviations above the mean. The above is important because it's positive. So I'm reflecting the fact that I understand that it's a positive number that's above the mean. That's one interpretation that just takes the z-score definition and kind of translates it. And then there's another way to process that, which is this: what percentage of the population am I taller than? Let's use that framing. So that's applying the z-score value, and we can do that. We did that in mod 6. This is the norm.s.dist, and I'm putting in my z-score, and I'm saying true. And I'm going to think about this as a percentage. And this is a very large percentage. And I have to be clear about what this number means. Remember, this is the area on the left of the curve. And so what that means is that if I draw do a quick sketch here, let me use the Excel tools. So I've got my bell curve here, give my drawing. 3 standard deviations up here. That means that 99.9% of the population is on the left of this person, right? So this woman who's 6 feet tall is taller than 99.89% of the population. And if I turn that around, I can make the other side of it equals 1 minus, and that's that. So there's 2 different statements. It depends on which one you want to be making, but this woman is taller than 99.89% of the population. Or this woman is shorter than 0.11% of the population. And they can be said in multiple ways. Like, this is the taller than, shorter than version, but I can say 99.89% of the population is shorter than this woman. And so you just have to kind of be very critical in your thinking about, well, what am I saying, and does that match the reality? I think the picture is helpful there. So we're going to go ahead and I'm going to stop that there because I think that's a good place to pause, and then we'll do another recording for the next part. That's distribution 1, distribution 2.